Alright, let us move on to the next question. Expression for energy stored in a capacitor, and another important 5 marker. Alright, so in this question, how do we move forward? Let us first understand the basic behind. You take a capacitor which has one plate and the other plate. Let us say this is charged to plus q, this is charged to minus q. How will be the charges to this plate? I have to be drawing inside actually. Okay, so if I take it this way, here inside you will be having charges plus, and here you will be having minus charge. So the direction of the charges, electric field direction will be something in this way. Okay, so that will be the direction of electric field inside from positive to negative. So electric field direction will be like this. Okay, to be honest, it will be in between the plates only. Okay, so first we need to learn the cases involved. The first thing is when you consider a capacitor which is initially uncharged. Okay, for example, you take a capacitor which is uncharged. Okay, meaning it is not connected to any battery. So when it is connected to a battery of potential, let us say V, what will happen is the plates will acquire charges plus q and minus q. Okay, so this will be the initial thing, that the capacitor, uncharged capacitor, when it is connected to a battery of say potential V volts, it gets charged, the plates gets charged to capital Q and minus q. Now in this, while reaching, as soon as we connect the battery, after some time this is the charge acquired. But what about in between, in intermediate case? So during the charging process, okay, we will first say that between the two plates, let us say the transfer of charge is happening step by step through a small charge, say dq. Okay, and while charging, I will write down here, while charging, somewhere in between charging process, let us say the capacitor is connected to the same battery and charging is continuing, it is not fully charged. Intermediate case, let us say the charge acquired is plus capital Q, plus small q and minus small q, and let us say the potential at that particular time is V dash. Okay, so we are trying to find an intermediate situation, an equation, so that once we find what is the way that the charging is happening, then we integrate, we will get the total work done in transferring the capacitor. Okay, so in the intermediate, while charging, what is happening is, while charging, let us say in some intermediate point of time, let us say the potential is V dash and the charges on the plates is plus q and minus q, small ones. Okay, and how is the transfer of charge happening? Through small transfer of charges, say dq. Okay, with this, now I will give you the initial explanation. You can make a note of it while writing these itself. With these three figures also you can put in the exam. So first thing is, consider a charge of capacitance C initially uncharged when the potential difference V is applied across the capacitor using a battery. That is the first figure which we have drawn. Consider capacitance of capacitor C initially uncharged. When potential difference V is applied across it, it acquires a charge plus capital Q and minus capital Q on the plates. Okay, that is the first line. Second one, consider a process of transferring the charge from one conductor to another. Okay, then during this intermediate situation, that is while charging, that I have drawn, what is happening? Let us say the conductors acquire plus small q and minus small q charge. At this stage, let the potential be V dash. So we have explained, and let us say small charge dq is transferred. After this you can write, first we will explain this line, this figure, then we explain this figure that just I dictated. I'll repeat if you want. For the first figure, you will write, consider a capacitor of capacitance C which is initially uncharged. Let us connect it to a battery of potential V. Then the charge acquired on the plates is plus capital Q and minus capital Q. Okay, while charging, after that you can directly go to the second figure. While charging, okay, let us say a small amount of charge dq is transferred from one plate to another. During this, while charging, yani during intermediate situation, let us say the charge acquired is plus small q and minus small q. Let the potential be V dash at this point. So we have explained everything here. Now the work done during this process is, what is the work done? So we'll write work done during this work done in this process, work done in transferring charge. Work done in transferring charge is, we can write work done in transferring charge, work done in transferring charge dq. Okay, that can be written as work done dw is equal to v dash times dq. Okay, which can also be written as v dash is nothing but q by c from the basic. Okay, so here it comes q by c times dq. So this will be your equation. How did v dash is equal to q by c come? We know this already. Okay, q is equal to cv is the standard formula, so v is equal to q by c is the formula. For intermediate situation is small q by c. For the first situation which we write, if I have to write for this guy, I'll have to write v is equal to capital Q by c. For this guy, while charging, I'll write v dash is equal to small q by c. That's all. So if you want, you can mention it. So after this, once you have got the equation, the next step, we have got an equation. What did we find till now is the small amount of work done in transferring a charge is dw. This is for dq charge to be transferred. What about the total work done? For that, we just need to integrate. So we'll write total work done. ठीक है, total work done to charge from 0 to कैपिटल Q, यानी प्लेट पहले 0 चार्ज पे थी, कैपिटल Q तक चार्ज करना है. दिस वी गेट बाय इंटीग्रेटिंग, यानी इंटीग्रल dw विच इज इक्वल टू w. सो इंटीग्रेटिंग ऑन द राइट हैंड साइड, इट इज q by c times dq, and integration is from 0 to capital Q. Okay, so you take 1 by c common outside, integral 0 to capital Q, and q dq is what you get. Okay, after this, it's simple integration. You take 1 by c outside, q का integral is q square by 2 with the limits 0 to capital Q. How did we get this? Integral of x power n dx is equal to x power n plus 1 by n plus 1. Okay, so using that you get this. After that, upper limit and lower limit to be substituted. Upper limit q square, small q square becomes capital Q square by 2 minus lower limit is 0. So that does it. So finally you get q square by 2c, q square by 2c. So once you get this, the next step is the work done is stored as potential energy. Work done is stored as potential energy, or you can also write work energy theorem. So you can write U is equal to Q square, just a minute, U is equal to Q square by 2C. So this is the formula which we wanted. Just go through once again. It's a simple question. Okay, the expression for energy stored in a capacitor, how do we solve? You need to know the three cases, intermediate case which I have shown you. फर्स्ट थिंग इज़, अगर कैपेसिटर को डायरेक्टली चार्ज करते हैं, थोड़ी देर बाद टोटल चार्ज उसके ऊपर आएगा प्लस कैपिटल Q और माइनस कैपिटल Q, पोटेंशियल V रहेगा. ड्यूरिंग चार्जिंग, यानी चार्जिंग के बीचों बीच टाइम लेंगे, लेट अस से एट दैट टाइम चार्ज एक्वायर्ड इज प्लस स्मॉल q एंड माइनस स्मॉल q, और पोटेंशियल लेट अस से इट इज़ V डैश. ऑब्वियसली small q will be lesser than capital Q. After this, we told, after writing the initial explanation, what is the work done in transferring a small charge dq? It is given by dw is equal to v dash q. dw is equal to v dash q. Once you get that, v dash is substituted using the standard formula, v is equal to q by c. So you got this equation. Once after that, the total work done to charge from 0 to capital Q is integrated from 0 to capital Q. Once you integrate it, take out c common, then integral of q dq, you got this q square by 2 from the integration formula, integral x bar n is equal to x bar n plus 1 by n plus 1. Once you get that, you just substitute, you get q square by 2c, q square by 2c. So this is the simple derivation which is asked many times, so you can easily understand this. Okay, further steps can also be done actually. If you take q is equal, just a minute, if you take q is equal to cv standard formula and substitute in this, what do you get when you substitute this? What do you get? instead of q you can write c square v square by 2c. C and c get cancelled, you will get half cv square. There is another formula. Okay, this also can be remembered. Again in this, if I substitute q equals cv, okay, so you get u is equal to half cv square. In that cv becomes q, so you get qv. Okay, so this is the third formula. So 1, 2 and 3, all the three formulas are important, learn all of them. Okay, and there is a very simple derivation. All you need to do was how to bring work done definition. After that, once you get that equation, you just have to integrate from 0 to capital Q. That's all with this particular derivation. I hope you have understood. You can go through. I'm just keeping on the screen so that you have a look what and all has been done. Okay, initial explanation I have already dictated. I think you can cover it up. Okay, so it's a simple integration. Right, I think we are done with this question. Thank you.